Hi guys, we're going to finish up before our last quiz here, and we're going to talk about section 1.3, which is on linear functions, slope, and applications. It's a little smaller screen. We're working on some things on my computer right here, so we're just going to have a little bit smaller than normal. So there's nothing wrong with your computer. It's just something new today. Okay, so a linear function. We talked a lot about this, and last week we were discussing that when you have a line, there are infinitely many points. You don't want yellow. So these lines have infinitely many points on them. And we talked about graphing them by the intercepts or an XYT table. And then I asked if any of you remembered, and a few of you did, this idea of mx plus b. This is a shortcut way to graphing. This is called slope-intercept form. And if you have the equation y equals x, or f of x equals x, that's the same thing as 1x plus 0. This is what we call the mother function of lines. It is a line that has a y-intercept of 0 and slope 1. Slope is a measurement of how steep a line is. And when you know that the slope is 1, in your mind, you should be picturing a 45-degree angle. So y equals x, or f of x equals x, so what we're going to call the mother function. There's also what we call a constant function where the slope is 0. So like y equals 2. If the slope is 0, you're looking at a horizontal line. It is still a function. That's why it says the constant function. It passes the vertical line test. And what this particular machine does is it turns all of the values that you plug into the machine into that particular constant. So let's look at a few examples here. Here is that identity, that mother function, y equals x. And here is just an oblique line with y equals mx plus b. Again, like we discussed last week, m is the slope or the steepness of a line, and b is that y-intercept value where it crosses the y-axis. Here is that constant function. And this is a vertical line. A vertical line is not a function. That would be x equals a number, like x equals 3, or in this case, x equals 4. It obviously is going to fail the vertical line test because at this point, it is being touched infinitely many times. And it's not a function because the only values being plugged in this particular machine is 4. So that's not what we're looking at for a machine. It is not a function. It's just a vertical line. X equals a number. So those are your specials. So again, if you want to write this down, you have a horizontal line. That's y equals a number. Slope is 0. And it is a function. A vertical line is x equals a number. We say there is no slope, or the slope is undefined, and it is not a function. If you get confused whenever you graph these, you can always make an XYT table. And if the table equation was y equals 2, you can just put 2 straight down here, and you can plug the 0, 1, 2 in for your x and graph it. On this guy, if it was x equals 3, when you make your XYT table, you can plug 3's down the row for x and your 0, 1, 2. And when you plot those points, it'll show you if you're dealing with a vertical or a horizontal line. So again, slope is the steepness of a line. A lot of times when I say slope, kids right away will say something about mx plus b. A lot of kids will remember to tell me rise over run. That's how your teachers taught you way back when you first started slope. If you spell the word rise incorrectly, like it kind of sounds like a Y, rise over run, that can help you remember the formula. The formula for slope is change in y over change in x. This is the Greek symbol delta. Delta means change in. And what this means is the change in y is the difference in your y's over the difference in your x's. We also call slope rate of change. And whenever you're dealing with lines, the rate of change is the same every time. So for this particular, the step is the same if you were going to build stair steps. So there's going to be an example here for you. They want us to graph this equation and determine its slope. So what do we have here? It says to calculate two-ordered pairs, plot the points, and graph the function. Okay, what we're going to do is we're just going to graph it. So y equals negative 2/3 x plus 1. You don't need to graph it to know the slope as long as you know what the equation is, mx plus b. The slope for this particular line is negative 2/3. That means you're going to rise negative 2 and run 3. If you were to graph it, when you graph, you start with the y-intercept or up 1. Then you start taking your slope from your point down 2, because if you're going to rise negative 2, you're going to go down 2, and you'll run 3. This line will be appearing to be downhill. You can do another point if you want because of the negative slope. So there is y equals that's a little messy. You guys are going to have to deal with that. Negative 2/3 x plus 1. You could also type it into your graphing calculator and get some points off the table if you were a little bit confused. Okay, so what types of slopes do we have? We have positive slopes if it goes uphill, and we have negative slopes if it goes downhill. When you're thinking of slope, if you compare them all to that slope of 1, that mother function, if it is bigger than 1, it will be steeper. The rate of change is higher, so it's growing faster. If it's less than 1 and closer to 0, it will be flatter because it's a slower rate of change. Once it gets to this 0 level, that's when it flips to the negative slopes. We already talked about a horizontal line has slope of 0, and that's because the rise over the run has a 0 for the rise, but it is running a certain amount. Let's say it's running 3. 0 over 3 is a number, and that value is 0. So there's no steepness. The rate of change is 0. When you have a vertical line, you are rising, but you're not running. So if you're not running and you have a 0 and a 4 on top, you all know, we just discussed this last week, you cannot divide by 0. That is undefined, or there is no slope. So vertical lines have no slope. A way you can remember this, if you have a horizontal line, you can make a capital Z out of it, and that's for 0. And if you have a vertical line, it spells the word no. So that's a nice little way to help you remember in case you forget. So they want us to graph x equals negative 2. My suggestion to you is to make this XYT table and just plug negative 2's down the road for the x value, because if x equals negative 2, that whole column is going to equal negative 2, and your y values can change. Plot the points and then connect, and you'll see you'll have a vertical line. If you're going to graph y equals a number, such as y equals 5/2, if you want, you can change that to a decimal, 2.5. If you make your XYT table, the equation is saying y equals 2.5, so we can put 2.5 down the row here, and then you have freedom of choice of what to plug in for the x values. When you graph it, 0, 2.5 would be here, 1, 2.5, 2, 2.5. You can see I'm looking at a horizontal line. I'm rising 0, but I am running, so the slope is 0. Okay, so some applications for slope. If you've ever heard of the grade of a road, that's talking about the steepness. A 4% grade means that the road is rising 4 feet for every 100, because 4% is out of 100. So the rise is 4 and the run is 100. That will help you whenever you're dealing with anything talking about grade. It's talking about a slope out of 100. So a federal law states that for every vertical rise of 1 foot, A horizontal run of 12 foot is required. Find the grade of the curb ramp shown in this figure. So if the rise is 3 inches and the run is 42 inches, what would the slope be? Well, it's 3 over 42, which you can simplify. You can divide both the top and the bottom by 3, or you can hit 3 divided by 42 and hit math 1 in your calculator, and you're going to get 1/14 for the slope. If you wanted to change that to a percentage, you could take 1 divided by 14, which is 0.0714, move the decimal, and you're looking at like a 7.14%. But I think that the fraction is going to be good enough. Average rate of change is another word for slope. The difference between average rate of change and slope is that only lines have slope. Lines have slope because it's the same constant rate of change. If you have any figure, but let's say like a parabola, I can use the slope formula to find the rate of change between those 2 points, but those 2 points will give me something different. Let's get a different color here. Then if I picked these 2 points, the blue points gave me a positive rate of change. The pink points gave me a negative rate of change. So when you say average rate of change, that means that you could get different values depending on what you picked. So we only use slope if it's a line because it won't matter what values, because if I pick these 2, it will simplify to the same thing as if I picked those 2. We call it rate of change if we're talking about any other figure other than a line. Regardless if it's a rate of change or a slope, you're going to use the slope formula or the rate of change formula, rise over run, y2 minus y1 over x2 minus x1. So here's a word problem for us. The number of people participating in the Federal Supplemental Nutrition Assistance Program has increased from 17.2 million in 2000 to 47.6 million in 2013. There's a graph that's going to show us the trend. They want to find the average rate of change from 2000 to 2013. Now, the reason they use the word rate of change is because this is not a straight line. But I can kind of treat it like a straight line and use these 2 points to find the slope still. And that would give me a rate of change. So that's what I'm going to do. I'm going to do y2 minus y1 over x2 minus x1. I don't know if you can see these very well. I have 2013, 47.6. And I have 2000, 17.2. The first point gets the 1s. The second point gets the 2s. We will use the formula. So I'm going to take 47.6 minus 17.2 divided by 2013 minus 2000. I'll go to my calculator. 47.6 minus 17.2, just typing that in my calculator, and I get 30.4. 2013 minus 2000 is 13. Go ahead and divide it out. 30.4 divided by 13. They're giving me a decimal. That's 2.33846. If I hit math 1, it gives me 152 over 65. Now, which one of these am I going to use? One's not more right than the other. But if you look at what you were talking about for your y's over your x's, the y's was the number of participants, and this is a year. So if I use this decimal and I put over 1, and this is in millions, you can see that the rate of change is about 2.3 million people per 1 year. And that makes a little bit more sense than this. 152 million people increase in 65 years. That doesn't make as much sense because we usually talk about the rate of change in a 1-year increment. So I think this will make a little bit more sense when talking about this particular word problem. Oh, they're going to do it too. Okay, so slope, intercept, equations of line, that's the mx plus b we talked about this a little bit already, is going to help us graph. The slope is the steepness, and the b value is the y-intercept. You start with the y-intercept, and then you're going to slope from your y-intercept. So when you get y by itself, it basically gets the equation ready to graph for you. So that's what we're going to practice doing now. I have 3x minus 6y minus 7 equals 0. Now I could add 7 here, and I can try to play the intercept game we did before, but I'm going to use slope-intercept form. And if it says to use slope-intercept form, it basically is just asking me to get y by itself. So to get y by itself, I'm going to subtract 3x, and I'm going to go ahead and add 7. Be careful with your negative. I have negative 6y is negative 3x plus 7. To get y all by itself, we're going to have to divide all the numbers by the negative 6. You're going to be careful with signs. I get y equals negative 3 over negative 6 is 1/2 x minus 7 over 6. So that's the slope-intercept form. So the slope is just the number. The number would be 1/2. That's the steepness. The y-intercept that they're asking for is a point. Y-intercept means x equals 0. The y-intercept value would be negative 7 over 6. So they'll want the slope and the y-intercept, and they're going to want that y-intercept as a point. We're getting close. If you're going to graph y equals negative 2/3 x plus 4, it's not wrong to check your calculator, but this is already in slope-intercept form. Slope-intercept form is really easy for you because you're going to start with your y-intercept, which is 4. So you'll go up 4, and then you'll put your point. From your point, you'll do your slope. The slope is negative 2/3, which means we're going to rise negative 2, and we're going to run 3. So from our point, we'll rise negative 2, which we talked about means go down 2, to the right 3. You can do it one more time to get an extra point. 1 would be enough, but sometimes it's nice to have 2 to make your graph look kind of nice. And you have a beautiful line. There's no proven way to predict a child's adult height, but a linear function can be used to estimate it. So, given the sum of the heights of the child's parents, we're going to take the adult height m in inches of a male child whose parents' combined height is x. They can estimate it like this. And the adult height female of a female child whose parents combined is x can be use it. So we're going to use those two formulas. Estimate the height of a female child whose parents' combined height is 135 inches. So the combined height is 135 inches, and they want a female child. So we need to figure out what formula we're using. We're going to use this one. We're going to plug 135 in for x, which is the combined height. So all you have to do to figure out f of x is take 0.5 times 135 minus 2.5. Plug that into your calculator. I turned my calculator off, it looks like. And I'm getting 65 inches. So 65 inches would be the predicted height of this child. Okay, the word problems usually aren't that bad, but they're not exactly the same. I'm sure you're going to have a couple more questions on that, and that's fine. So after this, you're going to look at your math lab, and you'll let me know if you have any questions.